Hi, welcome to You Do Not Understand Kerberos Delegation. My name is Daniel Lopez Jimenez. I'm currently known as Atlas on the internet. Those are my handles: Twitter, GitHub, YouTube. And from my side, I really like studying and understanding things about Windows, about Active Directory. I'm currently working at NCC Group, and I'm also teaching Active Directory security at Castilla-La Mancha University. If you are interested in my presentations, you can see all of them in my website, atlas.github.io. And I also recommend you watching our blog posts in chromis.club. So the goal of this presentation is understanding Kerberos delegation. Kerberos delegation has different types of delegations, and overall it's a credential delegation feature offered by Active Directory. So if we understand how this delegation works, we will know when to use it, when it is needed, and how to abuse it, depending on if we are on the blue side, on the red side, or if we are just an administrator. So why I'm doing this presentation? As I said, credential delegation is a feature quite needed in Active Directory domains for services. Not all the services will require credential delegation, but for sure some of them probably will. The abuses, talking about the offensive side, abuses of this subject do not require exploiting vulnerabilities or CVEs. We are taking advantage of the functionality of Kerberos delegation itself. And also, as a note, understanding this talk, this presentation, will probably help you in terms of lateral movement knowledge. You probably have had these issues when you access PowerShell remoting and then you want to, for example, run a command like net users whack domain, and the command responds you access denied or something like that. So this is a clear case of you don't have credentials in your process, so that obviously fails when you access the network, a service in the network. So before starting, a little disclaimer. We are not focusing on abuses so much. We will see some proof of concepts examples though, but we will be focusing on the how these delegations work. Obviously, I may have some errors or mistakes throughout this presentation. So if you spot anything weird or anything that could be written better or something like that, please contact me and inform me. I will be very happy to fix it or to change it. So I really hope you understand and you learn something out of this presentation. So the agenda is this one. We have a little introduction where we will simulate we have an organization and we need to create some services and stuff like that. And then we will encounter one problem, which is the double hop problem. In order to fix the double hop problem, we will see that credential delegation is needed. So after realizing this, we will start studying how Kerberos delegation, which is a kind of credential delegation, works. So starting with the introduction. Let's imagine we are in an organization, we have an Active Directory domain called capsule.corp. Okay? We have an internal web application, which is serbrowser.capsule.corp. And the goal of this application is uploading, downloading, and removing files. Just that. So this application is served by one server, and the files, in this case, the files that you are uploading and downloading, they are all stored in this path of the same server. Okay, web search support. So the application looks like that. If we are Vegeta, we can authenticate into the application, and we can start uploading or downloading or deleting these files. As we can see, the application is serbrowser.capsule.corp, and the server which is offering this application and which holds the folder where those files will be stored is web01. So this application obviously needs authentication, okay? In order to interact with the files and all the stuff, we need to log in. Note that this application only supports Kerberos, okay? Not because something weird, it's just that I configured this application to only support Kerberos, okay? Authentication is important because we want to identify who is connecting to the service, but obviously we want to we want access controls to control who is able to access our web page and who is not able to access. Okay, so if you implement Windows authentication in your service, you can configure ACLs, Windows native ACLs, for those objects your service interacts with. Okay, so for example, in this application, we know the web page is first listing the files of a folder, and then if you upload something or you delete one of those files, well, you will require certain permissions. So for listing the folder, we know the application or the principal that is using the application will need read permissions, okay? And for the other things, we will probably need write permissions. Okay, so we can see here that indeed the application is listing this folder, search support. And if you want to implement access controls in this folder, you can just go ahead and go to the security tab of this folder and configure different access control entries. For example, we can see that Vegeta has full access to this folder, both read, write, and full control. Okay. So how does this work under the hood? This works because if you implement Windows authentication in your service, the service will do something called client impersonation for the clients that connect to the service. Okay, so if you connect as Vegeta, the first thing that will happen is your credentials will be verified. If you are a domain user, the service will delegate that job to the domain controller. Okay. So once your credentials are verified, an access token, something called access token, will be created. And this access token will hold all your security context for local purposes. Okay. If you are Vegeta, the access token will hold your security identifier, your name, your groups, your privileges, your integrity, etc. So this access token will be placed into a new thread of that of that service. And then this new thread is the one that will try to access the folder where those files are stored. Okay, so in that case, Windows can verify who is accessing the folder and check the access control entries of that folder. If within the access control entries says that Vegeta has access, and Windows can verify that this token is Vegeta's token, then Windows can allow that thread to list the folder. So it's something like this. We have our web page in Web 01. This web page, in the end, it's running through the process web.exe. And this process has an access token working as the service account, which in this case is service account. Okay, and this is just an example. And we have here the folder where all the files are stored. So the idea is Vegeta authenticates into the service impersonates Vegeta after the credentials are verified, and creates a new thread where an access token of Vegeta is placed. Okay. As we said, this thread will try to list the folder, the share support folder. And Windows will verify both the information of this thread, the access token that this thread has, and the information given by the access control list of the shared support folder. If Vegeta has access, then, he has access. So far, everything is working properly. We don't have any specific issue. But now we will start with the problems, the double hop problem. So let's imagine that we have the same web application, but in this case, we are not storing all the files in the same server where the application is running. In this case, let's suppose that the web application is offered by Web 01, but all the files are stored in a remote share that is served by SQL 01. Okay? Something like this. Vegeta just sends the files into the application, and the service, the web server, the web service, sends those files on behalf of Vegeta to the remote folder offered by SQL 01. Okay, we configure it and we expect no errors, but suddenly when we authenticate as Vegeta into the application, we are shown this error. Access to the path SQL01 share support is denied. And we think, what the hell? And we go to the security tab of this remote share support, and we see that Vegeta has all the rights to list and to upload and to delete whatever he wants from this specific folder. So what is happening? What is happening here? In order to understand this, we need to go back to the basics. We need to understand how authentications work in Windows and how access tokens and logon sessions and credentials work in these authentications. So we need to differentiate interactive authentications from network authentications. An interactive authentication is the typical one we do when we, in the morning, go to the office, to our computer, and we log in physically, and well, our credentials, in that case, will be stored in lsas.exe. Why? Because of single sign-on purposes. If we log in our computer physically, our credentials will be cached in LSAS. And then if we try to, for example, list a remote shared folder, we will probably not need to specify credentials again, because Windows will use those that are cached in LSAS. Okay? So that's the important thing for interactive authentications. New logon sessions and access tokens will be created when we authenticate into a system. Okay? And the relationship between all these components is this one. We have our processes and threads. These processes and threads will have an access token representing us for local purposes. If we are Vegeta, we will have a Vegeta access token. And these access tokens will have an attribute, or I don't know how to call it, but will have the number, oh my god, I forgot how to say this, the identifier of the logon session associated to those tokens. Okay, so logon sessions are access tokens are referring to logon sessions through their identifier. And these logon sessions, if you are authenticated through an interactive authentication, these logon sessions will have tied credentials. Okay. In the case of network authentications, we had this example of, okay, in the morning in my computer I authenticated interactively, and then I tried to access a remote share. So if we try to access a remote share, in the target system there will be new logon sessions and new access tokens of ourselves. Okay, but our credentials will not be cached by the target server. Okay, in network authentications, the user proves that he has correct credentials, but they are not usually stored in LSAS. Okay, so the relationship is the same, but for network authentications, we don't usually have credentials. So the difference between access tokens and credentials is that access token represent the local security context of a user. If we remember the example of the web application and the folder that we saw earlier, we know that Windows, for all the access controls that does locally in a system, uses access tokens for verifying who is accessing this folder, who is accessing this file, in what groups is this guy member of, what privileges does this process has, etc. All this information is stored in the access token of a process or of a thread. Okay, but for network authentications, for network things, we need credentials, and we know credentials are tied to logon sessions. Okay, I usually refer to credentials as the network security context of a user. Okay, if you want to access a remote service, you will need credentials, either because you have them cached in LSAS for single sign-on, or because you specify those credentials when you try to access a service. But if you want to access something in the network, you will need, for sure, credentials. So all the relationship between all these things is something like that. You, as Vegeta, can authenticate into your computer interactively or remotely. Okay? If you do it interactively, you will probably have credentials stored in LSAS. If you do it remotely, you will probably not have credentials. When you authenticate, you are going to use probably Kerberos, if this is an Active Directory domain, or NTLM. Okay, those are authentication packages, or they have another name, Security Support Providers, SSP. Okay, the authentication packages are in charge of two main things. The first one is creating a logon session for your user. Okay, then they will take the identifier of the logon session created and provide this information along with all the security information of your user. This is your groups, your privileges, your identifier, etc. The authentication package will provide all this information to the local security authority, LSA. Okay, and LSA will create, with all this information, an access token for you. And you can see there is the user security identifier, the logon session ID, the integrity, your groups, etc. Okay, so remembering the access denied we had in the application, this is what actually happened. Vegeta authenticated interactively into his machine. Okay, this ended up with his credentials stored in LSAS, cached in LSAS, and a new access token, or more than one, created in the target system. Okay, when he tried to access Web01, the web page share browser, he needs to use his credentials to perform a network authentication. This results in a new logon session, or more than one, and a new access token, or more than one, of Vegeta in the target server. But when the service wants to save those files that Vegeta sent into the remote folder that is offered by SQL01, the service doesn't have anything to act on behalf of Vegeta. So the service tries to access the folder without any credential. And that is why the service, the SQL01, responds with an access denied. Because Web01 cannot act on behalf of Vegeta if it doesn't have any credential material that belongs to Vegeta. Okay, so this is what is commonly referred to double hop. Because the service doesn't have credential material of Vegeta, it can't access SQL01. So how can we fix this problem? With credential delegation. Credential delegation is the act of sending credentials to the service so that the service can act on behalf of his clients. Okay? We need something is that. So We need to remember that access tokens are just for local purposes. And for the network, we need credentials. Okay? So if we somehow configure the service with credential delegation, we would have something like this. Okay? Vegeta authenticates into his system. He has his credentials cached. And when he accesses the service, he delegates his own credentials to the service. Then the service can act on behalf of Vegeta to store those files into the remote folder. The remote system will have an access token and logon sessions, but obviously it won't have any credential cached. But in this case, Web01 does. Okay. The client, in this case, the client delegates credential material to the service. But we will see that not always is the case, that the client delegates his own credential material to the service. Sometimes we can configure the service with enough privileges to be able to access client credentials on his own. Okay? So the service doesn't depend on clients to act on behalf of them. So even if we are going to study Kerberos delegation, you need to know that there are alternative approaches. Okay? At the end of the day, we are providing credentials to the service. So there are different alternatives. A good example of this is PowerShell remoting. If we go to the documentation that Microsoft has about PowerShell remoting and the second hop, or the double hop, okay, you will see that we have several ways to fix this issue. You have, for example, the alternative of using create SSP. Okay, you need to configure the server to support this authentication, this kind of authentication, and you need to configure the client to trust the server, because the client will be sending full credentials without any constraint. Okay, this is very risky, create SSP, so be aware of using this one. But we have other alternatives where we can, for example, configure credentials hard-coded in the server. Okay, for example, a PS session configuration using Ranas, we need to configure the server with those credentials. And then when the client connects, the client will use those credentials for network-related things. Okay. We have here an example where we enter a PowerShell remoting session in workstation 02, and we see that if we do net users WAC domain, we have this awful access is denied. But if we enter this same PowerShell session, but through create SSP, which requires us to specify credentials, we see that in this case, net users WAC domain is working properly. Okay, so as we said, at the end of the day, the goal of any credential delegation is to provide a service with credentials, either because the client delegates those credentials or because the service has some way to access those credentials on behalf of clients. So we will see the start of what is Kerberos delegation, because in the next videos we will have a video for unconstrained delegation, another one for constrained delegation, and a final one for resource-based constrained delegation. Okay, so before starting with Kerberos delegation, you might think, hold on, why Kerberos and not NTLM? Well, this is because NTLM will require storing the password or the the empty hash of clients in the server they are accessing. These credentials would need to be verified on each access, which is not very optimal. And in regards of security, having a lot of empty hashes cached in a server is, well, not very secure. So the example would be like this. We have our empty hash. We access the web page through the network. The empty hash, the NTLM authentication is verified through with the domain controller, and if credentials are verified, the empty hash is cached in the server. So the server can use this credential material to try and access the remote folder on behalf of Vegeta. But this second access would need to be verified again with the domain controller. So we have two verifications per access, and we have empty hashes cached on the server. So this is not ideal. Okay. What about Kerberos? Well, Kerberos doesn't depend on any user password or empty hashes, and this is because Kerberos or services that implement Kerberos trust the tickets and session keys that we are using. So they don't need by default to contact the domain controller to verify if those tickets are valid. If the service can decrypt the ticket and verify that is not an expired ticket, then we are all set for running this. Okay. You should note, though, that having tickets and session keys cached in a server, even if it's way better than having empty hashes or clear text passwords, it is still a risk. So it's very important that you know that any delegation service is always a sensitive access you need to protect way more than other kind of assets. So this is the introduction. Active Directory has 3 different flavors of Kerberos delegation. We have unconstrained delegation, constrained delegation, and resource-based constrained delegation. So in the next video, we will start with unconstrained delegation. Thank you.